Okay, so for this lab, there's just, like I said in class, there's a lot here. There's a lot of distractions today. We'll do the best we can here. So the bottom line, what we're trying to do is basically you're going to take some brass, ultimately, and you're going to just annihilate it in nitric acid. It's going to be fun. It's going to create a disgusting brown gas that you can't breathe in. It's going to go away, and the copper will be dissolved in the solution. Okay? So once that happens, then we're going to try and figure out the concentration of the copper in that solution based on essentially the depth of the color. Okay? Because the more concentrated it is, the more of certain types of light it's going to absorb, and the more of other types of light it's going to transmit or reflect. Okay? So the problem with this is this lab is kind of built as a two-part lab, and the first part we did not do. Okay? The first part was supposed to just get you familiar with how the spectrophotometers work and everything like that. Okay? So I'm going to have to familiarize you with that stuff tomorrow when you first come in, but it's not bad. It's basically some of the vernier stuff. So it's similar, very similar to the temperature probes we used before, except this time you're basically taking a little, it's called a cuvette, and it's basically just this little square test tube, okay? And you're putting the solution into it, and you're dropping it down into the spectrophotometer, and it will pass light through it and measure how much of that light gets absorbed and how much of it gets transmitted, okay? And then it will give you data on the computer. So I'll have all that stuff set up for you so that hopefully it'll be fairly easy coming in to just collect the data you need to collect, all right? So the context for the investigation, this is kind of interesting because this is one way that they can actually, in a brass shell casing, they can figure out the mass percent of copper, and they can tie that a lot of times to one particular manufacturer. And so that can help figure out if there's no other markings on the bullet, they can figure out maybe who made the bullet. So kind of an interesting application there. So as far as the pre-lab here, the main thing I just want you to be familiar with exactly what we're doing tomorrow when you come in, because that's the better you feel about what we're doing when we come in, the faster you're going to be able to do it. And if we can get the first two parts done tomorrow, then I think we'll be fine on getting the data collected on Wednesday. All right? So the first part here, first step, we basically have to figure out the relationship between wavelength, concentration, and absorbance. Okay? Now, wavelength and concentration we're familiar with. Absorbance, we might not be so familiar with that term. But basically all that means, all absorbance means is how much light is something absorbing when you shine light through it. Okay? How much is it letting through? How much is it absorbing? Okay? So we can actually measure that. So basically, I'm not going to tell you what that relationship is yet. I will tell you that on the next video that we do. Tomorrow is more for just kind of figuring out, tomorrow is more the inquiry part of this lab, and then really Wednesday is more the you just do what the lab tells you to do sort of thing. Usually when it's not a good idea to do an inquiry lab involving 15 molar nitric acid. Hey, knock yourself out, you know, whatever you want to do, just go ahead. So we won't do that for that part, but for this part, what you're going to do is you're going to be given two different solutions, okay? And salt solutions just means an ionic compound, all right? So you're going to be given, out of these 6 right here, listed in step 3, you're going to be assigned to 2 of those in your group. And basically what you have to do with those solutions is you have to measure the absorbance at every 20 nanometers from 400 up to 700. Now, again, I will show you exactly how to do this on the vernier stuff tomorrow when you come into class, okay? But what you're going to do is you're going to use that to determine the best wavelength to measure the absorbance of the solutions, okay? And it says make sure you use the appropriate spectrophotometer. You only have one choice there, all right? So you don't have to worry about picking that. And then you're going to be sharing your absorption spectra with the rest of the class to identify what species in the solution is actually absorbing light, okay? So here's the trick. Basically what you guys are going to do, sorry, where is it? Let's say that you are assigned to the copper 2 sulfate and the zinc nitrate, okay? What you're basically going to do is you're going to measure the absorbance at certain wavelengths, okay? So you're going to set the wavelength, I can't remember whether they have you do wavelength on the x or y axis here, but let's say that we're graphing wavelength on the x-axis, absorbance on the, that would make sense given the normal convention because we're varying the wavelength. That's kind of our independent variable here, and then we're measuring the absorbance. But basically what you're going to get on a lot of these is something that kind of looks like this. It will peak at a certain wavelength. That's where you get the best possible absorbance for that particular chemical. Okay? And so you're going to make that graph, basically. And you're going to use this data for a couple of things. You're going to use this data to figure out, number one, what is the best wavelength to measure these at, so that when you come in tomorrow, or not tomorrow, but on Wednesday, when you come in on Wednesday, you'll be able to say, all right, for copper, we want to use a wavelength of 500 nanometers because that's the one that gets the best absorbance, okay? Or we're going to use 400 nanometers because that's the one that gets the best absorbance. Okay, so that's one thing you're going to be able to figure out based on the class data tomorrow. The second thing that you should be able to figure out based on the class data tomorrow is what it is that's actually doing the absorbing, okay? So for example, in copper sulfate, there are actually two things. There's copper, and there's a polyatomic ion sulfate, right? So the question is, which one of those two is actually causing the solution to have a color? Right? Same thing with zinc nitrate and zinc sulfate. Which one of those two is actually causing the solution to have a color? And then the iron nitrate and the iron sulfate, okay? You may be able to figure this out basically just by looking at the solutions tomorrow, but we're going to actually test it to make sure. We're going to look at data and see if we can figure out what it is that's causing the color to be the way that it is. Is it the cation, the metal, or is it the anion, the polyatomic ion? Okay, it's giving it its characteristic color. So those are the two things we're going to be able to figure out based on the class data that we should get tomorrow. Step 4 and 5, really, that's going to be what I do. That's going to be my video for tomorrow, okay? So my video for tomorrow will basically explain these extension questions here, okay? But then a couple other things that I want to point out. Determine the mass of a 1 to 2 gram sample of brass. You don't have to do that yet. I guess the two things that I really want you to do for tomorrow, the two things I want you to get done is this, okay? You're going to measure your two solutions at the different wavelengths. Now, everyone should have their own spectrophotometer. This should move fairly quickly once you get it going, okay? But then the other thing that I want you to try to do tomorrow if you can is actually get your solution made, okay? And that's going to involve me putting some 15 molar, basically 16 molar nitric acid into your brass, okay? And then we'll do that reaction, and we'll try to get to step 3 if we can, okay? So that you will have made your solution with the brass dissolved in the solution, okay? And then if we can do that, then you should be able to do everything else. Step 4 on, you should be able to do on Wednesday, okay? But I want you to notice this. There's a couple of things that you have to do here. On step 2 of the procedure, you have to calculate, assuming your brass sample is 100% copper by mass, calculate the minimum volume of concentrated 15.8 molar HNO3 that needs to be added to react completely with the brass, okay? You're not going to be able to make this full calculation until you get into class tomorrow, but I want to give you kind of an idea of how you would calculate it because this is sort of a complicated calculation. All right? So let me open up something else here. Actually, I don't know if this will be faster or slower, but I'm going to try it.
I scare you a little bit?
Yeah.
Plus, I want to make sure I get this reaction right because it's kind of complicated. Okay, let's try. That really bothers me. What's that? No, I'm not. Sorry. I'm just... No, it's not. I'm just trying to do something here, and it's not working. Where is it? Oh, there it is. Okay. So, what you have to do here, and I don't know if this is faster or slower than me just writing it, probably quite a bit slower, but this way I make sure I get it right. This is the actual reaction of copper with nitric acid, okay, if you put it in acidic solution. You need to know this reaction in order to be able to stoichiometrically figure out how much, what volume of nitric acid you actually need in order to completely react with all of the copper, okay? So, an example here, let's say that, I've got 1 gram of brass, okay? Now, they're saying assume, on the lab, they're saying assume that that's 100% copper. Now, we know that's not true, okay? But just for the sake of making this calculation easy. So if we've got 1 gram of brass, we're going to assume that's 1 gram of copper, okay? Now, notice this is a 1-to-1 ratio here in the equation, okay? So basically, we can go from grams of copper to moles of copper using 63.55. Okay? Where's my calculator? So that's telling us we've got about 0.0157. I'm not being careful at all with my figs here because I just started with 1 gram. You're going to have a much more specific number than that tomorrow. But we've got that many moles of copper, okay? So in order to completely react all of the copper, that's how many moles of the nitrate we need as well, okay? So that means that we need 0.0157 moles of NO3 minus, okay? Which also means, because HNO3, when it dissociates, it's a 1-to-1 ratio. So that also is telling me that I basically need 0.0157 moles of HNO3, okay? Now, so I know how many moles of HNO3 that I need in order to completely react with the copper. How am I going to get from that to a volume of nitric acid that I need to add in order to make this dissolve? Okay, so I use the molarity equation, right? Now we know the molarity is 15.8 molar for this nitric acid, okay? So that equals 0.0157. I'm just going to write over all this writing now. Divided by our volume, okay? So then you basically just solve for your volume there. And you're going to end up with a pretty small number, but that's going to be liters, right? 15.8. 15.8. Yes, that's right. So 9.96 times 10 to the negative fourth liters. Yeah, that's true. Yeah. All right, and then you times that by 1,000, of course, because we need it to be in milliliters. So that's going to be about that's not very much. 996 milliliters. And we have to add to this thing. That's really not very much at all. Huh.
Why did I get
Yeah, it's for 1 gram, but they said to add 1 to 2 grams, right? So, yeah, we're not working with very much here. Now, we are going to dilute this quite a bit. We're going to end up diluting it down to 100, up to 100 milliliters. So we'll have a good amount of the solution ultimately, okay? But bottom line there might be maybe use a little bit closer to 2 grams so that we can at least use a milliliter of the nitric acid when we're adding it, okay? This is not exactly how much you're going to add tomorrow, right? How much you're going to add tomorrow is going to be based on, I keep doing that, it's going to be based on what this number is initially, okay?
Okay, I know what
And so this number initially, whatever it is for you when you measure it, you're going to need to substitute that in for what we just did here and then do that process very quickly at the beginning of class so that you can get this made, okay? So that's the basic idea there. Now, what else? There's one other thing that I think you have to do here.
What did I do wrong? Thursday?
Okay. Actually, you know what? This number 4 here is actually a calculation you'll need to make for Wednesdays. So I'll hold off on explaining that. Not that I really need to explain it. It's just an M1B1 equals M2B2. So I think you'll be okay there. But I will talk about that on my video for tomorrow. Okay? So again, just kind of reiterating here. What you need to do for tomorrow is you need to
Oh, I know what I did. I was doing 517.
be ready when you come in to take whatever solutions that I assign you, and you're going to make graphs of those based on their absorbance at different wavelengths. Okay, so you're going to start at 400, you're going to go all the way up to 700, and you're going to measure the absorbance values that you get in the computer for those different numbers. Okay, then you're going to make a graph. It can be just kind of a rough sketch, and honestly, even without making a graph, you should be able to see it, right? Because it's going to be whatever your highest absorbance is. And then you'll have an idea of where to set your wavelength when you do the copper the next day, okay? So really, tomorrow is just to get you familiar with the spectrophotometers and how they work, okay? But then the second thing we're going to do tomorrow, hopefully, calculate, after you measure out the mass of your brass, calculate how much nitric acid needs to be added into your brass, and then make that solution so that it'll be ready for you when you get started on Wednesday. Okay? Does that make sense? No questions there? Okay. All right, so we'll see you guys in class tomorrow.
Adios.
Yeah. Adios.